Without further ado, I'm really excited to announce our next presenter. One of my old colleagues, actually, it's Mark Vandewill. He is the field CTO from Fivetran, and he's here to talk about data, in and out data. Is it any good? So during this presentation, we will have 5 minutes at the end for questions. So feel free to ask your questions in the comments section. If we do run out of time, we'll be sure they're addressed after the event. So yes, with that, I'm very pleased to introduce Mark. Welcome, Mark. Thank you.
Thank you, Meredith. And yes, I'm very excited to present here on entropy. Let me see. All right, so in and out data, is it any good? So what I'm going through today is a quick introduction. I will talk about data replication. That's been in my throughout my career. I will talk about CIA, what it means, and how we talk about it in this context. And then I also want to cover specific examples on how customers use, data validation, data quality measures in the context of replicated systems. And then, as Meredith mentioned, we'll have Q&A at the end. So with that, quick introduction. So this is me, field CTO at Fivetran. I joined Fivetran as part of an acquisition. I worked for HVR since 2014. HVR was acquired by Fivetran just about 2 years ago, October 1st, 2021. Throughout my career, and I hate to say, but there's some gray hair appearing on my head. Over 20 years of experience, worked in a combination of data replication vendors, and then on the other hand, analytical data use cases, vendors who provide data analytical databases, whether that's Oracle on the data warehousing side or Actian with the vector-based database. So data replication. Now, I went back and thought about entropy, right? So the theme of today's conference, and I thought, well, in my physics classes, when we talked about entropy, the conclusion or the rules of nature is that entropy only ever increases. So we talk about decreasing the complexity and decreasing quality issues, but ultimately, I think entropy only ever increases. So I used my creative freedom here to just highlight in an image how I think about entropy, and also what I on occasion observe in some of our customer scenarios is that the chaos only increases. It doesn't actually get reduced. But anyway, that's as a start to my presentation. So let's talk a little bit about data replication, because when I think about data replication and when I look at what our customers try to do, data replication is never an objective in and of itself. The organizations don't replicate data for the sake of replicating and duplicating data. The goal is always something else, and it is the path to get to this something else that leads them to replicate data. So here we have a word cloud, and ironically, the word cloud ended up with cloud in the center of it, which I thought was a great detail that I wanted to highlight. So the reasons why organizations want to replicate data, they want to adopt the cloud, right? Like the previous speakers also spoke about the evolution of IT infrastructure, the adoption of modern data stack, as it's sometimes referred to. Like organizations are gradually moving to the cloud. We see enterprises being a little bit further behind relative to some of the startups in today's market. But that's absolutely a trend that is ongoing and continues to go. Organizations consolidate their data. They have use cases where there is a need for access to consolidated data, and that's the reason why data gets replicated. There's machine learning, there's artificial intelligence use cases, there's compliance use cases. We have, as an organization, the need to keep track of our data. So why would we not consolidate it in a data lake for longer term storage? There's availability use cases. There may be performance reasons why we replicate data. We have this heavy analytics to perform, and we can't afford to do it on the operational systems because it would end up slowing down the organization, or it would end up slowing down the processing. And with that, we generate less revenue. We can be less competitive if we did so. So those are the reasons why people replicate data. Again, it is my conviction organizations do not replicate the data just for the sake of replicating data. So with that, they don't introduce the chaos on purpose, but it might happen as a side effect. Now, if you look at today's market and you think about cloud as one of the themes, of course, that we've seen throughout the last couple of decades, cloud, ironically, has resulted in more and not fewer needs for replication, because what's happened is more and more applications got created for specific individual use cases, right? Like there might have been a situation that your organization used a single system, a single, maybe complex, but an ERP system, let's say, that managed all of the aspects of the business, whether it's supply chain, whether it's inventory management, whether it is human resources, whether it's CRM, whether it is project management. All these individual aspects might one day have been managed out of a single system, maybe out of a single database, or certainly out of relatively few environments. Nowadays, however, we have applications and data sources for almost every aspect of the business, right? We're using Workday for our human resources. We're using Salesforce, of course, for CRM. We're using Zendesk for support management. We're using maybe still that ERP for supply chain, but then inventory management is somewhere else, et cetera, et cetera. There's a multitude, there's been an explosion of data sources. And as a result of that, going back to the reasons why we replicate data and data consolidation and machine learning being such an important attribute of today's market, we've only increased the need to replicate data, and with that, introducing the challenges that come with replication. So that led me to introduce to you this concept of CIA. And CIA is an acronym that I came across the other day, and I thought, well, just for irony's sake, let me just put up an image here on my slides that show CIA. But that's not the CIA that I'm talking about. I'm not talking about the Central Intelligence Agency here. What I'm talking about, and you can find resources on the internet about CIA talking in the context of data quality. I'm talking about the idea that we want data to be complete, we want its integrity to be fully managed, and we need accuracy. So let's dive into some of these aspects, right? So from a completeness perspective, when data is available to our users, to our business, it has to be complete. It has to be fully there for the business to be usable. And that, of course, makes full sense. But if you think about this in the context of data replication, what if we included incremental data on a portion of the data, but for other data sources, we only have, let's say, a daily sync of the data. So throughout the day, as we're looking at the most recent data set, we don't have a complete data set, and that is a problem, right? So completeness is a very important aspect of the data. We want to get all attributes of the data. If let's say the source schema changed, right? So there is now additional data fields available on our system, whether those come through a SaaS application, software as a service application, or it comes out of a database, or it comes out of a file, or it comes out of a data stream. We always need to have complete access to data in order to be able to have essentially no chaos on the destination side. We talk about integrity, and integrity is related to completeness, but also has separate aspects to the data as well. From an integrity perspective, with my background in databases, I like to talk about database level integrity. And there's this age-old example on integrity as it relates to the financial industry, right? I transfer money from my account to somebody else's account. And it's got to be a scenario where, from a transactional consistency perspective, the money gets deducted from my account and gets added to the other person's account in a single transaction. So, and I don't want to be able to see part of that transaction. It's either I go from a situation where the money is fully in my account to a situation where the money is completely in somebody else's account, but it cannot be that the data gets deducted from my account, and it didn't show up in the other account. There's integrity examples in the database world related to parent-child relationships, transactions that span multiple tables, all of which we need to care about in the context of, well, entropy, or let's say the lack of chaos at the end of the data, or at the end of the data flow, right? Like if we consider in and out data, and we do not want to introduce issues from a data perspective, we have to be concerned about the data integrity of our data transfer. And then lastly, accuracy. So how can we make sure that the data is in fact accurate? How do we make sure that it is the correct representation of the source? Sifflé, being originally a French company, of course, you're well aware of in French-speaking countries data that uses accents, right? Like different encoding of the data. That data, when it gets replicated, it still needs to be reflected correctly. We don't want to end up in a situation that, let's say, some accuracy got lost along the way, and as a result of that, we're no longer representing the data correctly. Could be accuracy from an encoding perspective, could be accuracy from a numeric or a date time perspective. In all cases, we have to make sure that the data is accurate. So how do you go about this then from a validation perspective, right? Like imagine we're replicating the data, and now what, right? We have a replicated data set. How do we know, how can we ensure that this data set is correct, or how can we ensure that the business is using that data set as if they were accessing the source systems directly? Now, it's all built around trust, and I'm highlighting trust here not to state the obvious, but the reason why I highlight trust here is because, first of all, we can of course have trust in the technology as a foundation, right? Like we look at the vendors, let's say, pitch deck, and we believe what they're saying. So, and if we believe what they're saying, we trust that they do their QA. And as a result of that, we believe that when we use their technology to replicate the data, we trust that the data on the tail end of that replication is correct. There's an alternative method that I highlight here, is a checksum. Checksum is a very aggregate process. It is incredibly sensitive to let's say, lack of consistency, lack of accuracy. The checksum ultimately creates a string value of a data set. And by running this over aggregate data sets, we can come up with a very small measure at the end of the day that validates whether the data is indeed correct. An obvious disadvantage of this approach is that with that checksum, we have very low information on the details. But it is absolutely a way, if all you're interested in is knowing whether the data that went in is the same as the data that came out, then checksum is a great way to do this with a bunch of processing, but not a lot of data transfer involved. We can look for patterns, right? We can sample the data, and we can identify whether, hey, is the data on the surface, does it look correctly? And if it looks correctly for the sample that we that we used, we can go back to, again, the point of trust, where we're assuming that, hey, if we're looking at this set of data and that happens to be correct, well, then the other aspect, then based on the trust that we have in the tools, in the utilities, in the solutions that we're using, we do believe that the data is indeed correct. And then the last one that I'd highlight is a detailed comparison, right? We could go through a painstaking effort of saying, well, you know what, we have all this data on the source, we have all this data on the destination, is it in fact identical? With that comparison, of course, on active systems, we have to take into consideration that data continues to flow, at least if we're doing a real-time replication. But even if we didn't, then still the source system, right, the transactional application where the data originates, that system continues to evolve, continues to update its data. And we need to take that into consideration, of course, when we do this painstaking comparison, unless, of course, we could take a snapshot point in time. So let's look at a few examples. And those are real-world examples. These are customers that I work with on a, well, I'd say daily, but it's luckily no longer daily, but at least on a weekly basis. I interact with these customers who use these different examples in the world of replication. So the first example here is an online retailer. It's a very large online retailer, well-known organization, and they have a system where they replicate financial data. Financial data is, of course, regulated data, so it is incredibly important that it's correct. And this organization wants to report financial results out of the replicated data set. So from that perspective, even the SEC is going to require that this data is exactly the way it's supposed to be. The source in this particular example is an Oracle E-Business Suite system. Destination is a data lake that resides on S3. And what this organization does for its data validation is a detailed comparison. So they will go through painstakingly and exactly identify whether every data value is identical. And only if that comparison shows that the results are indeed correct, are they willing to accept the data replication. And if there are challenges with the replication, then we will get informed. The obvious disadvantage of this approach is that it's incredibly resource intensive. I highlighted on the previous slide, and I mentioned that if we do a detailed comparison, we have to take into consideration that data may be moving. Now, in this particular example, this customer does have an approach in getting a snapshot of the data. So in their case, they managed to work around this from the perspective of the data validation. They do get a point in time validation and then indeed have a foundation level of trust that if based on, and these are some very high volumes that they're replicating, based on that, based on the validation, point in time validation that they did, that indeed the data then is correct. Second example is one in supply chain optimization. This is a CPG, so consumer packaged goods organization. They have an example where it's critically important that the data is correct. We talked about integrity in the context of the CIA acronym that I used, or that I introduced here. The supply chain optimization scenario requires transactional consistency. It is important that as this organization determines how many of every one of the items needs to be shipped to the point of sale out of the warehouse that is under their management, that they get exactly updates between inventory and the plans, the shipment plans, etc. The source here is SAP. This is right now is an S4HANA environment. Destinations are both SQL Server and Kafka, and there is a transition going on here to more of even more of a streaming use case. And in their scenario, the data validation is based on row count. Now, row count is, of course, a relatively simple way to validate the data, and it gives you a base level of understanding of the data replication side, but then again, it does require a foundation of trust. Ultimately, this organization, of course, they've been using the replication for several years, so they do have that base level of trust, and then use the row counts to get a feel for, let's say, at a particular time of the day, during a part of the week, they have a feel for, okay, based on in-flight data, what can be the differences of row count. So, and for them, it's a scenario that works. But of course, the tools, solutions like Sifflé are still providing additional background, additional validation that organizations will use on occasion. And then the last example is a large insurance company in the United States. They have a data warehouse / BI, business intelligence use case. In their scenario, they go from numerous operational systems into Snowflake, and you can imagine that from an operational perspective, claims, customer support, or like customer client management, of course, very important applications. In their case, they want to go about validating by using an approach to looking at the operation counts. So on the destination side, they have a full representation of the history of the data, and then want to validate that during a particular time window, the number of operations that were reported to be changed on the source, broken down by individual operations, let's say new rows, modified rows, and removed rows or removed items, that those operation counts at a high level aggregate up to the same result based on what they see on the destination side, where the full history is represented. Now, a big challenge in this environment is that you want a consistent and reliable interface to validate against. And of course, one can argue that, well, the data replication solution is that consistent and reliable interface. But of course, that's a catch-22 situation, because if you consider the extreme example of this, where the replication solution would report that there's been no changes, and indeed on the destination side they see no changes, then the validation would not highlight an issue. But of course, there would be, in all likelihood, an issue, assuming that the organization operates as it's supposed to, as it continues to be in business. So, so these are three approaches that I think we can all learn from. I think those are great examples on how organizations in the real world manage data validation in the context of data replication. So what I talked about, quick introduction, chaos, right? How do we end up not introducing chaos? Data replication, talked a bit about why organizations replicate the data, and again, convinced it's never a goal in and of itself or an objective in and of itself. We talked about completeness, integrity, and accuracy of the data, and then we walked through a few examples. So with that, Meredith, I wanted to see if there's any questions from the audience that we can address here. Thank you.
That was fantastic, Mark. Thanks so much. Always great. I'm loving the knowledge sharing and learn something new, CIA. So thanks for that. So folks listening in, please feel free to put your questions in the comments area, and we'll try to address. We have a few minutes left before we head to our break. So Mark, here's one that just came in. Question is, what is your perspective on using a probabilistic approach to data quality?
Yeah, that's a great question, Meredith. So the probabilistic. So fundamentally, if I think about data replication, I take a pure view on data replication, and I think, well, we have to be able to get this exactly right. So, and of course, if you think about exactly right, then if you use a probabilistic, that's a difficult word to pronounce, a probabilistic approach to data quality, then I think that's arguably not good enough. However, I do see that in the real world, for many organizations, if they consider like, okay, what's the business challenge that we're trying to resolve here, and how accurate do we have to be? I think that for most businesses, the probabilistic approach is probably good, is good enough for the vast majority of the use cases that are out there, simply because as a data replication vendor, you look at the problems differently than you look at it from a business perspective. And again, I think a lot of the business use cases will be fine with a probabilistic approach to data validation.
Thank you for that. It's a problematic word. All right, here's another one. So what are some issues you've seen in data replication that cause out of sync conditions?
Wow. Yeah, so that's some issues that we've seen, and this goes back to some of the technology approaches that we use, but I'll just highlight a few here that we've seen. It happens that source systems have corrupted data. So, and when I say corrupted data, I look at it from a replication perspective. So if the database indicates that it uses a particular encoding, then fundamentally we should only find characters or bytes in the database that are valid within the context of that encoding. And it happens that that the bytes that we retrieve out of the system do not match a valid character. So what do you do in a case like that, right? Like you can then grind to a halt from a replication perspective, or you could choose to adjust the data and put in, let's say, a substitution character to highlight like there was a data corruption. So we see corruption issues. There are, so, and from a replication perspective, we like to go to using log-based replication. And for log-based replication, because of the foundational aspect of the transaction log to database processing, we believe it's a strong way to do replication. However, there are some operations that are known to be filtered out, that are not included when doing log-based replication. This is ultimately a database level or a database technology perspective, and we'd like for customers to be aware of this, but not everybody is. And so it happens on occasion that data changes are simply lost as part of the replication because an operation was performed that should known to not ever be replicated. So those are issues we see. It also happens that between technologies that the accuracy of data types is not identical, right? So numeric data types or date time fields, right? Like some systems represent date time down to whatever, 1,000th of a microsecond, a nanosecond, right? Like if you do not have an equivalent representation of that on the destination side, whether you like it or not, you're going to lose some accuracy. So those are some examples where we've seen, let's say, issues coming up in the replication side that are, well, to some extent avoidable. In other cases, more difficult to deal with.
Right, and it's all about having the right tools in place to identify those moments.
Exactly.
So, well, with that said, Mark, I believe that's what we have for questions. I want to just give you a sincere thanks for sharing your knowledge today and joining us.